I just recorded. So there are 3 tasks for today. If you see the section 4, it's just showing disable 3 of the 7-segment display and only show the number on 1 of them. It's just the AN keyword, right? So yeah. Yeah, just turn on 1 of them, right? Turn on 1 of them and display it and throw the code to it. So it should be able to only display on 1, either one. So that one is pretty simple. And second one is show FLC, so 3 different letters on 3 different display units. And I already provided most of the part over here, so you just need to start. Yeah. So each state is displaying 1 letter, right? So state 00 only display 1 letter. It doesn't have to be. So this code is probably L, not F. I couldn't remember which one, but you can change it easily. So, but within each state, you just update it, increment it by 1. So next time, whenever the rising edge arrives, the clock is cycling, right? So every rising edge of the clock is gonna trigger whatever entry in here in the following code. So if the first rising edge enters this state, because state was 00, so the first time it has to enter this entry here. But at the end of the entry, it adding 1 to it. So that's why next time the next rising edge of the clock is going to enter the state of 01 instead of 00. Okay, and then it's adding 1 after at the end of it. So next time, so the next rising edge of the clock will enter the next. So just keep adding to it. Yeah, it's going to be 1-1, and I think you only need the three states because there are only 3 letters. Never
works. My third if statement, it just never works. I'll show it to you.
Okay. You may need a. You don't need a 4. You don't need a 4 because you are actually giving a static binary number to AN, to the keyword. Yeah. So you don't really need to do anything to the 4th one. You just which one you wanna turn on, just turn on. Okay, so you only need the 3 states. But if you are cycling through, you probably need the 4th one, which is giving like all the LEDs are off. Just turn all of them off. Since you have to, if you are just keep adding 1 in the loop, then you cannot skip it. In that case, you'll probably need a 4. But this one is pretty easy, it's a static. But for the next one, it's asking you to roll the 3 letters from right to the left and then come back to the other side, right? So this one, it's actually two states or 2 counters. If you think about it, how that works in the digital manner, it looks like it's a static 3 letters moving to the left, but actually it's 2 counters. The first counter displays the 3 letters, and the second counter move it to the left. So which counter do you think runs, or which counter should have a bigger value, you think? So a bigger value of the counter means shift to the left has a bigger counter, so it's slower. It should be, right? Yeah, because the display should scan really fast, so your eye cannot resolve it. That's how it shows 3 letters on it as a static view or looking, right? But when it shifts, you don't want to shift it that fast, otherwise you want your eye be able to resolve it, but not the other way. So that's why I have 2 counters here. One is 1,000. So how fast is it going to reach this 1,000 here? How long it takes?
1 over 1 times -7.
It should be 5, I think, because 1,000 you have 100,000 of 1,000 in 100 mega. You know what I mean? So 100 mega divided by 1,000, you are getting how many? Should be 100,000, right? The 100 million divided by 1,000, you are getting 100,000. So it's actually 1 out of 100,000 second. It's triggering that count for once. So you got two counters. The first counter, the counts, the first counter, which is count max, right? Count max is in charge of shifting the three letters to the left, and second counter is in charge of no. So the first counter is in charge of do the blinking, do the display, and the second counter is to shift everything to the left. And so whenever the second counter reaches the 100 million, whenever it reaches 100 million, what is this doing here? So one thing I have to let you guys know, because in the future I have to use this a lot. So AN is this is a module, this is not a test bench, right? So AN here is just a variable, it's not a physical keyword. But the thing is, I cannot wait. No, AN is the one you can do the concatenation. See, you can shift and do all the operations, the manipulations to it. That's AN, but AN is a keyword. But this is not a test bench. I don't think. I forgot why I have to do it for the module. I remember it's just, you just have to do it in the test bench because you cannot do the shifting for the keyword here. I don't think that really matters. You can try either one, okay? But I think if you follow this kind of pattern, it should work as well. So what's happening is I'm having a intermediate variable, which is ANN, to manipulate the bits in there instead of directly manipulate the bits in AN, because I found out in test bench you cannot do the shifting in AN. It's a keyword, but this is not a test bench, so I'm not really sure. It's either way. I think if you follow this pattern, it's okay. Just keep using AN as an intermediate. So I just what I did was I just declared another variable here, AN, as an intermediate variable. So I'm doing all the shifting and concatenation with it, but eventually I'm just assigning this one back to AN, so it's eventually still doing something to AN. But this is not a test bench, it's just a module, a sub-module. And eventually this will be included in the test bench, and this AN here will be directly shorted to AN keyword. If you don't want to waste too much, because running every time you synthesize a code in Vivado takes a lot of time, I would probably recommend you guys just directly using this pattern. And if you are still curious about it, you can just delete AN and directly do the shifting with AN in the sub-module and see if that works. But you don't have to. If you just follow this one, you just eventually assign AN back to AN, okay? So I'm just providing part of it. It's just the first state. So I have to use two counters. So the counter 2, whenever counter 2 reaches a smaller number, the bigger number of the counter. I have a question here for you guys. So the bigger number of the counter is in charge of what? So what I'm trying to do is roll the FLC 3 letters to the left, right? So what is the bigger counter doing here? It's a bigger number, right? So it seems like it takes a second to reach that 100 mega. What is that one doing? It's shifting to the left. 1 second, every second it shifts one position to the left. So why I'm doing this over here? Yeah, the shifts. It shifts. So it's changing the initial state of the AN, right? So you eventually, so at the very beginning, it may have the lower 3-bit or 3 units being activated, but next time, whenever it reaches, so after this, whenever it reaches the second, it shifts everything to the left. by 1 bit. So to activate the upper 3 units instead of the lower 3 ones. So the smaller count is doing what?
The rolling of the
No.
letters.
That's the one to display.
It displays each one. It's displaying. So the smaller counter display different letters on the 3 units.
Yeah.
Because smaller counter it definitely will reach this smaller number faster than the bigger one. That's why it's actually scanning these 3 units really quickly to display different letters on the different units.
Why do we need a clock? Why can't we just blocking assign it the first F and then blocking assign the L and then blocking assign the C?
But where's the time reference? So you need a reference for the time. You are thinking about simulation.
Well, no, on the board, like, why do I care about what time it's uploaded at?
That's why I called it rolling, because it's only lighting one at a time.
Right, so why don't I just, as fast as possible, light up F, L, C, and then go just as fast as possible back to F?
But what is the time reference? How do you do that?
Why do I need to reference the time?
If you don't have a reference to the time, how do you assign them, like what you're talking about, fast enough, right? So what does that mean? Compared to what is fast enough?
Well, it would just update the F1, and then we'll update the L, and then the C, and then as soon as it's done with that, it'll just update the F. Like, why do we have to wait?
But you are still talking about as soon as, the soon, what does soon mean, right? So you need a reference.
Right, so instead of waiting 1,000 clock cycles, why don't we just immediately go to the next letter?
And it's just like the delay.
Yeah, like it just goes through all the commands instead of waiting for the clock cycles.
How do you provide that? It's the hardware, it's not the software. It's not taking out instructions like the Arduino does. There isn't a crystal is doing that thing.
I just don't get how that's different than when you have the 1,000 count delay, I guess.
So just let me know what you want to delete here.
I don't want to delay anything. I want to take out all of the counters. Like, why do we need the counters?
Because it just needs a time reference, right? So the clock is 100 megahertz. Then it's the only thing is doing a timing stuff for the entire circuit.
Right, so I'm saying, why don't we just, instead of trying to time the circuit, why don't we just have the circuit run as fast as it can and then restart over? And then just...
It's not running back and forth. It's not a software. It's not taking every instruction. These are not instructions. These will be synthesized into hardware. These are just circuits.
So why don't we just make the circuit not have to use the counter at all?
Use the circuits, not use the counter. If you use the circuits, it's static. It's static. It's not changing, right?
Be trying to assign multiple states to something at the same time.
Well, that's why you have to do it with blocking statements.
It's not coming back and forth it's not a loop, right? It's just a static circuit. You need something to drive it, like a clock. So it's changing all the states. Otherwise, the states
You
aren't.
still have the always this positive edge clock.
Yeah.
But then it would just, instead of having all the if statements, it would just run through the code, update all the 7 segments, and then.
Oh, so don't have the counter?
Yeah.
It's too fast, I think. Because the LEDs are still analog circuits. It needs some time to charge up the caps, internal caps, and give enough energy into it. So we want to slow it down, actually.
I guess it conserves power.
Yeah. It just won't work if you just directly use, for example, if you don't use a counter like 1,000 here, but just to use the 100 mega clock to switch in between all the units, you won't be able to see anything because it's just too short to charge up the pin junction of the diode. It won't light up.
That makes sense.
Yeah. And you won't be able to roll it, right? Because there are different timing. How do you roll
For the
it?
rolling, it makes sense. Just
Yeah.
for just displaying.
Okay. Yeah. Good question though. You just need to slow it down to charge up the. So what's the name of the capacitor? No, what's the name of the capacitor in the pin junction?
Yeah.
the diode, right? It's a LED, it's a diode. What's it called? Junction capacitance? CJ, that's what I can remember. Yes, there's a capacitor in there, parasitic.
That's to overcome that.
Oh, we did talk about the parasitic.
Yeah, it takes time to charge it up. It's definitely not an ideal component, not a superconductor. Okay, I think today is a very good chance for you guys to build that Schmidt trigger. If you don't think so, you can build it anytime in 602, but if you build it here today, I'll be able to help you with the oscilloscope. I didn't talk about it, but I'm going to revise this a little bit. It's in the lecture's instruction.
The homework's the one we're reading.
Yes, so it's over here.
So the homework's due. I don't understand the due date still. The homework is due on Thursdays and the lab is due Wednesday night.
Yeah.
Is it Thursday before?
Before the class, yeah, 11:15. No. I didn't say that you should show the oscilloscope results, but you should. I'm gonna start adding the details to it. Take a picture of the circuit and including the 3 nodes. Remember I drew on the paper, so you can already upload the notes and the video to the website. If you click it, you'll be able to see what I really need for the report. For task 2. So you should show the waveform at the so from the oscilloscope for node 1, node 2, and node 3, right? I haven't done that yet, so I'm just curious about that. See if this is what we as what we predicted, you know. So the one should be a floating edge but noisy, and the filter has a delay, and after the Schmidt trigger it should be clean edge. Let's see if that works. Does that make sense? Could you build it today? It's a super simple circuit. It takes you maybe 10 to 15 minutes, hopefully. Works? Okay, let's do it.
Is it that exact circuit?
Yeah.
What are the resistor? What's that left-hand resistor value for the pull-up 10K?
Oh, 10K, yeah. Yeah, 10K. And the Schmidt trigger is on the top left corner of the rack, and it's in the middle. 74H14. 7 is 14, H14, I think.